So we have the electron arrangements for the first 20 elements, and an electron arrangement gives the number of electrons in each energy level within an atom. And so you could just basically look into your book and any periodic table. First element on the periodic table is hydrogen. Elements are arranged by an increase in atomic number. There's hydrogen. It has 1 proton. Therefore, it has 1 electron, neutral atom of it. So what you could do for hydrogen is say hydrogen equals 1. This is what your book uses. No other chemistry book I've ever seen or class uses it, but I'm going to use what your book uses. Hydrogen is 1. Helium is the second element, so it has 2 protons. Therefore, it has 2 electrons. And so the electron arrangement for helium is 2. Now when we go to the next element on the periodic table, we have lithium, which has 3 protons, 3 electrons. Its electron configuration is going to be a little different. It's going to be 2 and then 1. Go back to the Bohr model, the thing you learned about probably in high school or middle school. That first orbit is only ever going to have at most 2 electrons in it. So this would be a helium atom in the Bohr model right here. But for lithium, it has to have a second orbit. So here's your nucleus. There's the first orbit, and here's the second orbit. The first orbit's going to have 1 and 2 electrons, and then the next one is going to have just 1. And that's what this here is indicating. The 2 means there's 2 electrons in the first energy level, and the 1 means there's 1 electron in the second energy level. The next element is beryllium, which would have 2 in the first and 2 in the second. So if I was to draw that over here, let me erase lithium and just write in beryllium. You would put a second electron right there. Then we have boron, which again has 2 electrons in the first. This has 3 electrons in the second energy level. Just like that, and so for boron. The next one would be carbon, which would be 2, then 4. Okay, so there would be the Bohr model for carbon. Then we've got nitrogen, which would be 2, then 5. Oxygen would be 2, then 6. Fluorine would be 2, then 7. Neon would be 2 and then 8. So neon would have 1, 2, 3, 4, 5, 6, 7, and 8 electrons in that second orbit. Then we would move up to the next energy level, the third energy level, which is why we go to 1 row lower on the periodic table. Yee, that's a bad one. And we have sodium. So sodium would have 2, 8, and 1. So now I'm going to put 1 electron there. And then we've got magnesium, 2, 8, 2, so on and so forth. until you get to argon, which is 2, 8, and 8. So if I'm drawing argon over here, a noble gas, you have 1 in that second or third energy level, 2, 3, 4, 5, 6, 7, and 8. And it says the first 20 elements, so argon is the 18th element. We have to go down to the 4th energy level to get to the 20th element here. We're running out of space, but we have, after argon, we have potassium. So potassium would be 2, 8, 8, and 1. And so you would write in potassium, and it would have, in that 4th energy level, it would have 1 dot in there. And then finally, element 20, calcium, would be 2, 8, 8, and 2. And so you would put a second dot there, and you wouldn't write calcium, you would write, or potassium, you'd write calcium. Okay, so it's very easy, and the way your book is doing it, these elements, we're not looking at what would be called the orbitals within these elements. We're just looking at how many total electrons are in each energy level. So here you've got the first energy level, the second energy level, the third energy level, and the 4th energy level. And it stops at calcium for a reason, and that reason is the next one, which would be scandium, actually puts its 21st electron into what would actually be the 3rd energy level, even though it has 2 electrons in the 4th energy level. And so your book doesn't want to make things more difficult than it needs to for you, being a survey class of chemistry, so they stop at element 20. The table here shows you the first 20 elements, their atomic numbers, their symbols, and then the number of electrons on each energy level. And you can see, looking closely in here, hydrogen has 1 electron in the first energy level. All the rest of them have 2. Hydrogen, helium have 0 electrons in the second energy level. Lithium has 1 in that second. Beryllium has 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, neon 8, and then all the rest have 8. And this would repeat for the first 118 elements, the ones that we've discovered. And then again down into sodium, you've got 1, 2, 3, 4, 5, 6, 7, 8 electrons in that 3rd energy level, which would continue forever going down to element 118. And then the 4th energy level, potassium and calcium have 1, then 2, and so on and so forth.